The discovery of gravity is attributed to Sir Isaac Newton, a renowned mathematician, physicist, and astronomer in the 17th century. Newton formulated the law of universal gravitation, which describes the gravitational attraction between objects. The story goes that Newton was inspired by observing an apple falling from a tree. While this popular anecdote might be simplification, Newton indeed wondered why the apple fell straight down to the ground rather than sideways or even upwards. This curiosity led him to contemplate the nature of this force. Through years of research and mathematical calculation, Newton developed the law of universal gravitation, which states that every point mass in the universe attracts every point mass with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law was revolutionary because it explained not only how objects fall on Earth, but also how celestial bodies, such as planets and moons, are attracted to each other in space.
The invention of the internet can be traced back to the 1960s when the US Department of Defense initiated a project called ARPANET, the Advanced Research Project Agency Network. ARPANET was designed to connect computers at various research institutions, allowing them to share information and resources. In 1969, the first successful ARPANET message was sent between two computers located at UCLA and the Stanford Research Institute. This event marked the birth of the internet as we know it today. Over the new few decades, the internet evolved and expanded with the development of key protocols like TCP or IP, Transmission Control Protocol, or Internet Protocol, and the World Wide Web by Tim Berners-Lee in 1989. These innovations made it possible for information to be transmitted across a global network of interconnected computers. The internet continued to grow exponentially, becoming more accessible to the public in the 1990s with the advent of commercial internet service providers and web browsers. This led to a rapid increase in the number of websites and online services, ultimately shaping the modern internet landscape we rely on today for communication, information, and commerce.
First is its bullet, which is the gunpowder, which is invented in the 9th century. The invention of gunpowder in China during the 9th century marked the beginning of the development of firearms. So, China initially gunpowder was used for fireworks and other purposes. So, early firearms, 14th to 15th century. By the late 14th century, early firearms like the hand cannon had emerged in Europe and Asia until now. It became more advanced. Firearms research and material science advances in material had led to development of more durable and lightweight, like what we have in our present times. While firearms have had military and different applications, they have also had significant societal impacts, includes debates of gun control, violence prevention, and public safety. The history of gun is marked by technological advancements that have led to more accurate, reliable, and powerful firearms. These developments have not only influenced warfare but also had implications for forensic science, material science, and societal discussion of gun control and safety. History of mobile phone and its contribution. Mobile phone dates back to the 1940s, but it's not until 1960s that researchers like Douglas H. Ring proposed the idea of cellular networks, which laid the foundation for modern cell phones. First mobile phone call in 1973 by Martin Cooper, an engineer at Motorola made the first handheld mobile phone. Throughout the 1980s, cell phones became smaller and more portable thanks to advances in microelectronics. And then in the 1990s to 2000s, SMS and mobile internet has been developed, and cell phones more versatile, enabling text messages and basic web access. So, in global connectivity, cell phones have bridged the digital divide, providing people in remote areas with access to information, education, and healthcare. The evolution of cell phones from bulky devices to sleek smartphones has not only transformed the way we communicate, but has also played a pivotal role in advancing scientific research and technical development in various fields.
Telescope. The telescope first appeared in the Netherlands. In October year 1608, the national government in The Hague discussed a patent application for a device that aided seeing faraway things as thought nearby. It consists for a convex and concave lenses is a tube. The combination magnified object 3 or 4 times.
Processed food. In the past, early preservation techniques in ancient times throughout history, people use various methods to preserve food, such as drying, salting, and fermenting. These techniques help extend the shelf life of food items. Canning in early 19th century, the invention of the canning process in the early 19th century by Nicolas Appert and later improved by Louis Pasteur led to be a breakthrough in food preservation. This involves sealing food in airtight containers like nowadays like mega, like instant food. This involves sealing food in airtight containers and heating it to kill bacteria and prevent spoilage. So health and sustainability concerns in the processed food is the proliferation of processed foods has also raised concerns about their impact on health and the environment, leading to ongoing research into topics like food additives, processing methods, and sustainable packaging. So, in overall, development of processed food has been driven by scientific advancement in preservation.
A microscope can be traced back to the late 16th and early 17th centuries, with various scientists and inventors contributing to its development. One of the key figures in the history of the microscope is that scientist Anthony van Leeuwenhoek. In the 1670s, he developed a simple yet powerful microscope with a single lens, which he used to observe microorganisms and other microscopic structures for the first time. Its observation and meticulous documentation laid the foundation for the field of microbiology. Another significant contributing came from Robert Hooke, an English scientist who in 1665 published a book called Micrographia. In this book, Hooke described his observation using a compound microscope and coined the term cell to describe basic unit of life. Hooke's work not only expanded our understanding of biology but also revolutionized the way we perceive and study living organisms. The invention of the microscope and subsequent advancement have had numerous contributions to scientific development. Number 1. Advancement in biology. The microscope has been instrumental in studying cells, microorganisms, and other microscopic structures. It allowed scientists to explore the intricate details of living organisms, leading to breakthrough in cells biology, microbiology, and genetics. Number 2. Medical discoveries. Microscopic examination of tissues and cells has played a crucial role in diagnosing diseases. Understanding their mechanism and development treatment, the microscope has enabled the discovery and study of bacteria, viruses, and other pathogens, leading to advancement in medical research and the development of vaccines and antibiotics. Number 3, material science and nanotechnology. Microscope equipped with high magnification and resolution capabilities have contributed to the study and understanding of materials at the atomic and molecular levels. This had led to advancement in nanotechnology materials, in science and development of new materials with unique properties. Number 4, forensic science. Microscopy techniques are extensively used in forensic science for the analysis of trace evidence such as hair fibers and fingerprints. This has been crucial in criminal investigation and the administration of justice. Number 5, environmental and ecological studies. Microscopes have been essential tools for studying at diversity and behaviors of microorganisms in various ecosystems. They have contributed to our understanding of ecological processes, the impact of pollution, and the identification of new species. In summary, invention and development of the microscope had a significant impact on scientific development. It has expanded our understanding of the microscopic world, revolutionized biology and medicine, and contribute to advancement in various scientific fields. The microscope continues to be a crucial tool in scientific research and discovery.
The discovery of the benzene ring is credited to Friedrich August Kekuli, a German chemist, in the mid-19th century. Kekuli proposed the structure of benzene after having a dream about a snake biting its own tail, which led to the realization of the cyclic structure of the compound. Prior to Kekuli's proposal, scientists struggled to understand the structure of benzene, which was known to have a molecular formula of C6H6 but exhibited properties that were inconsistent with other known compounds. Kekuli's proposal of the benzene ring, composed of 6 carbon atoms bonded in a hexagonal ring with alternating double bonds, explained the stability and unique properties of the benzene. The discovery of the benzene ring revolutionized organic chemistry and had significant contributions to scientific development. First, structure and bonding. The benzene ring introduced the concept of resonance, where the electrons within the ring are delocalized, explaining the stability of benzene and its unique reactivity. This concept became fundamental in understanding molecular structure and bonding in organic compounds. Second, aromaticity. Benzene was the first compound identified as aromatic, leading to the development of the field of aromatic chemistry. Aromatic compounds play vital roles in various biological processes and have applications in pharmaceuticals, dyes, fragrances, and polymers. Third, synthetic organic chemistry. The discovery of the benzene ring opened the door for the synthesis of countless organic compounds. It provided a framework for understanding and predicting reactivity of behavior of aromatic compounds, enabling the development of new molecules and materials. And lastly, drug discovery. Many drugs and pharmaceutical compounds contain benzene rings or aromatic moieties. Understanding the behavior of benzene and aromatic compounds has been crucial in drug discovery and the design of effective pharmaceuticals. Overall, the discovery of benzene ring by Friedrich August Kekuli had a profound impact on our understanding of organic chemistry, leading to advancement in various scientific fields and contributing to the development of new materials, drugs, and technologies.
The invention of radio can be attributed to several key contributors, but one notable breakthrough was made by Guglielmo Marconi in the late 19th century. Marconi successfully transmitted the first wireless telegraph signals across long distances, culminating in the historic transatlantic radio transmission from Cornwall, England to Newfoundland, Canada in 1901. This achievement laid the foundation for modern radio communication and sparked further developments in radio technology.